Okay, now let's look at the relationship between the Bernoulli process and the discrete distributions that we looked at. Okay, and this is explained in the textbook around this section. So let's open the Excel file. Okay. Now, what we want to do is to assume a Bernoulli probability of, okay, let's first set up a Bernoulli process. So probability of 0.05. Here we'll insert the distribution Bernoulli. Okay, and the probability of success is that one. Okay. Now let's make that absolute reference. So we will now set up several Bernoulli processes. Okay, let's say we'll do 1,000 of those. So we start off with 1, 2, then highlight the entire column, and then the series step values 1,000. Okay, so that's going to fill in 1,000 trials. So let's say copy this Bernoulli process to the rest of the cells. Okay. So when we simulate, so this is going to come out to be either 0 or 1 with probability of success being 0.05. So if we go ahead and sum this column, so that's going to give us how many ones there are. So that this will be like a binomial distribution. Now the first failure is, you have to be a little creative in setting this up. That is, what we want to do is we want to go down here, and when we get to the very first one, we want to look at the trial number. That will give you the trial number when the first failure happens. And we can do that using Vlookup, and we want to look for the number 1, right? And you want to look for number 1 here in this range, in the first column actually, and then output the value from the second column of this range. So that will give you the trial number. And we need to include exact match. We don't want approximate match. So you have to select that. So it'll be, okay, it should be false for exact match. Okay. So right now they're all 0, so you don't have one right now. And then the item before, okay, so this will be the negative. So you want how many failures before the first success, okay, or geometric. So this will be that minus 1, right? So if you change the lookup value from 1 to any number greater than 1, then you will have negative binomial. But when it is 1, you get geometric. So failures out of 30, so that will be like a binomial with trial equal to 30. So that will be that. Okay. Now, Now we'll compare this information that we're going to get. Okay. Well, let's go ahead and set this up. So we want to make these into outputs. So we want that to be a risk output. Okay. That to be a risk output. And that to be risk output. So that will be risk output. And then we can compute risk mean of that. And then risk standard deviation of that. Okay. So then we'll copy these two down here. So when we run the simulation, these will get populated. Now you want Poisson, right? So Poisson, you want 1000 trials, right? The probability of success is 0.05. So 1000 times 0.05 will give you the lambda. So here we can say risk Poisson. Okay, so that times 1000. Okay. Now we want negative binomial. So let's go into the distribution. Negative binomial. Okay, so this P is that, and it's really geometric. So if you say S is equal to 1, that will be geometric. And we can compare risk negative and negative binomial and risk geometric. Risk geometric is only that probability because that's the first number of failures before the first success. So now we can, well, we have to make these output. Okay, so we have now described all three to be output. Then we can copy that here. So we'll get the mean and standard deviation. And then for exponential, okay, which is actually a continuous distribution. We haven't discussed it yet, but let's go ahead and set it up just for comparison. We'll come back in and check it out when we discuss continuous distribution. So exponential, here the beta in this case happens to be that. Okay, and it's going to look like this. And again, let's put the output there, and then a mean and standard deviation we can copy over here. Okay, so now we are ready to simulate. So go into settings, make sure so they're okay. Okay, so now we have the answers. So the first one, so that is binomial. Okay, so this one is negative binomial, or in this case it's uh, geometric. So here is directly, simulated separately negative binomial. It's approximately the same. So here we are simulating from uh, from the 1000 trials, whereas here we are simulating using the formulas, and therefore it's a slight difference because the seeds will be different. Okay, and the exponential distribution is this. We'll come back to this and compare. So uh, so here is Poisson and negative binomial and geometric.